My name is Brien Colwell. I'm the co-founder and CTO of Headspin. My talk today is about a process that we developed at Headspin to help mobile teams collect the data that they need to make good decisions to continually improve their user experience. So I'm assuming most people here are app developers or part of a mobile team, and I'm guessing that one of your goals is to deliver a high-quality user experience to all your users. So no matter where they open the app, anywhere in the world, making sure they have a great experience. What most teams find challenging is that once their app launches or they're launching new features on a continuous basis, they're struggling to kind of keep that quality high. So I know when I launch an app, I'm continually watching the stars in the app store, seeing how they're fluctuating day to day, and trying to collect issues that seem important to fix, and constantly fixing what seem like the highest priority issues. One place that's natural for teams to start once their app is live, or even before they launch their app, is actually starting with the cloud. So the APIs and the content that powers the app. So you can start adding instrumentation, logging, events to track how the API is performing, how the content's being served. And this is a natural starting point. You can collect a lot of data by adding hooks on your server side. When you get to the user side, or the phone that the user's using out in the wild, you can add some analytics, but typically developers find it's hard to instrument too much on the user side because the amount of data being collected on the user side adversely affects the user experience. So the more data you collect, the more user data you use, the more battery you use. It's really hard, for example, to upload too many screenshots or too much verbose logging from a user device. Also, when users use your app, they're in a bunch of different conditions. So they're opening it in different network conditions, different environments, and it's really hard to get a repeatable user flow or a clean user flow across with enough data to actually test and debug what's going on. So at Headspin, what we focused on is a process that sort of inverts the amount of data to put more data from the user perspective for developers. So the user perspective is the join point between everything that powers the app. So between the internet services, the network, the app code, your APIs, it all shows up on the user. But typically this has been the hardest point to get the high fidelity data you need to make decisions. But once you have rich user data, you can actually start prioritizing decisions and making better informed decisions. And being more measured about how you're fixing your app and what you're prioritizing. So in our process, when we think of high-fidelity user data, we think of 5 areas. So what the user sees on the screen, what the user hears, and what the user says into the device, which is becoming more important as voice interfaces are becoming more common. The cell and the Wi-Fi networks that the device sees, the user input, how the user is actually touching the device, how they're interacting with the device, and also what's happening inside the device in the GPU and the CPU. So to capture this high fidelity data, what we focus on in our process is actually these 4 data sets, which capture enough of this user experience to actually make meaningful analytics of the user. So the first is the high quality 60 frames per second video of the screen. This is very important to start developing AI models about what the user is seeing, the content, how the content's changing. Bidirectional audio in and out of the device at the operating system level. So this is really important as apps, for example, start from a Siri experience and sort of transition into an app and then back into a Siri or a Google Assistant. All the packets from the app user space, so going out over the real cell networks or the real Wi-Fi networks, you see a lot of richness on the client side that can't be seen on the server side. The client side captures all the data about how the app's actually using the network, how the network is affecting the app, which can't really be measured anywhere but what the device sees on the network. And also the user input. So the user is the one driving the app, and there's a lot of richness and subtlety in that input. There's a lot of best practices on how input should be reflected and how the app performs that without the high fidelity user input, it's hard to track back what the user is actually experiencing. So to get at this high fidelity data sets, these 4 data sets, we actually spent a lot of time building out a new type of data center, a new distributed data center with the reliability and the scale of a real data center or sort of a single location or concrete building data center. So we started with a unique RF neutral plastic wind tunnel design. So when you're using real devices, bloating, temperature control is really important. So anytime you're running a device farm, it's basically a best practice to keep them a lot of wind going through the device. It'll extend the life of the device. It'll let you run, at higher load, and also let you run at room temperature. Which, if you're really focusing on distributing a data center, room temperature was very important for us to be able to put this in areas without temperature control. So we also focused on designing custom servers that sit in this box that run at above room temperature. So there's a lot of sort of work in this area. For example, Wi-Fi AP deployments, running sort of servers out there in like really extreme conditions. So we built some servers similar to those type of environments to let us run sort of high processing power at room temperature within these boxes. We also custom built USB hubs that let us finally control the sync and the power to the devices. We embedded custom Bluetooth headsets within the box that creates a bidirectional audio communication with all the devices in the box. So 24 devices fit in this box. And then typically when you have a real data center, the thing that you really like are smart hands. So people are actually in the data center 24/7 available to do tasks. So if you're talking about taking devices out of a data center to start collecting this really valuable data, one of the things you'll start missing most immediately is actually the smart hands. There's no one there, to do anything with the device if something goes wrong. And typically this is where a lot of reliability issues start to creep up because essentially over time devices drop off or sort of become unavailable. So we actually built out an automatic smart hands that sits within the box. We call it an e-finger, and it can do manual maintenance on the devices remotely. So we can deal with MDMs, which are becoming more important on devices. So security rules where your IP needs to be pin locked, for example, or pin locks popping automatically on devices are becoming more common. And we can also do reflashing or sort of any type of maintenance on a device with our e-finger. So all this was a new way of thinking about a device cloud that is a massively distributed but maintains 24/7 uptime and chain of custody on the devices. This also has a touchscreen system that tracks who takes devices out. So this is what we started to try to get out this data set. And what we did is we basically put these boxes all over the world. So we have boxes in 6 continents, everything but Antarctica, over 100 major cities around the world. We have real devices running on real cell networks, running workloads, and essentially enabling this type of user experience monitoring to help developers prioritize problems and understand what's actually happening in their apps. So about 3 years ago, we started this process with our devices and with our deployment that we call mapping the experience genome. So we wanted to understand where the user experience problems were happening in the apps and how those correlate to user groups. So a lot of app developers are familiar with running a user group and getting feedback from real users. This is incredibly hard to do at scale. It's incredibly hard to do continuously. But we thought that if we understood what the elements were of feedback, when people say, I didn't enjoy this app experience, if we could build AI models that would automatically characterize the app experience and give feedback to developers on a continuous basis, we could use these models to essentially guide mobile teams to fix the issues and understand what the users are seeing. So we broke down the genome into two types of issues. So the first we call user experience issues. So these are the issues that pretty much anyone could tell you is an issue. So it's very layman language. It's anyone could understand a user experience issue. How we built these issues are we actually just spoke with a lot of users and ran a lot of user groups and categorized feedback on what are all the types of feedback for how people were saying the app had a bad experience or there was a poor experience. So this wasn't necessarily whether they liked using the app or not, whether it was an app that they liked the content, but really, if they wanted to use this app and if they were trying to do something with this app, would they come back to it? Would they use it again? Did they think it accomplished the goals correctly? So we ran a bunch of user studies and combined the results into these 6 categories. So this is what we call the user experience genome at Headspin. These are areas that we actively look at for all the data to, at a high level, tag the data with regions that users would see as suboptimal experiences. So the first we call page load. So page load is either a warm or a cold load. It's just when you open the app or when you transition from screen to screen, how long did it take for the content to stabilize and become consumable, or for the app to become interactive again? So this is a really rough top-level metric, but incredibly useful because typically there's a bunch of loading screens and potentially interstitials and different steps that happen before the app is usable. And people are pretty good at actually telling you, when the app is usable. They'll just sit there and watch the app load until, this thing seems like it can be interacted or consumed. So what our page load issue here represents is just, what a user would say, the time for this app to become consumable. The second is loading animations, so otherwise known as spinners or sort of like animated interstitials. These represent some kind of background task or something that the app is doing and the user's waiting for the app to complete. Typically, spinners are almost always an issue. So when people see a spinner, what we found is it's just typically something that they view as a bad experience. The next type of issue we look for is what we call low page content. So this is aligned with sort of an information theory perspective, but essentially, typically people have a good experience with apps that have high information on the screen. So, for example, if there's blank screens or like a single piece of text that's not a form or something, there's a bunch of edge cases here. Like forms are usually pretty low content, but are interactive. So if there's sort of these screens that are not interactive with low content, these are typically seen as poor experience. So, and you'll see this a lot in apps where there's kind of the blank screen issue. So there's just a blank screen that's standing in for something, or a big blank box that's supposed to be filled in with something that's loaded. This is a kind of universally seen as a poor experience. The next is progressive loading. So progressive loading is an interesting one because essentially, for example, you'll see this a lot in carousels or sort of lists that scroll really fast where content's sort of streaming in sort of reactively. At some point, it starts at kind of a low content and then creeps up to a stable high content. And it's sort of the slope and the time it takes to go from the low to the high that's sort of perceived as how long the user's waiting. This is something that users do notice. If it takes too long for all the images to load or for the for that profile picture to load up, these are noticeable things to users. The fifth one we call responsiveness. So typically it's good practice, and a lot of design guidelines suggest when the user taps on something or interacts with the screen that there's some visual response. Usually if there's not a visual response, that's a sign of a problem. Also, if the visual response is too long, that's also the sign of a problem. It's potentially just a bad experience, like too many animations or something. So we actually measure responsiveness and try to quantify, when it's sort of either not there or too long. And the final category is actually the most subjective and interesting, which we call generally low quality. So particularly in the video. So a lot of people understand what this means from signals like blurriness in live video, or blockiness or jerkiness in live video. So what we do is actually indicate that as well in the data. So we look for sort of some of these perceptive signals and raise them up for to help kind of guide in where users would perceive these. So a lot of live streaming apps, media apps have these type of problems, as well as communication apps. So you'll see a lot of these quality issues in those areas. The second type of issue that we kind of built out as part of our genome mapping is we call kind of hidden signals, and they're client-server issues and purely client issues that are root causes for user experience issues. So these are a bunch of anti-patterns that are affecting the user experience, but that may be hidden because they're sort of deep down in the network behavior or the application behavior. And some of these, for example, are the way that the app is using the network stack, the way it's using security, the way that the infrastructure is set up, for example, even things like DNS, the way that content is being served, the type of content being served, and different optimizations that can be done on actually the server-side deployments. So a lot of times apps that are scaling globally need to become global on the back end. And a lot of issues start to creep up when, for example, the edges aren't keeping up with the user base. We also look at graphics and CPU. So that's the type of genome mapping that we've been doing at Headspin. And next I'd like to show some examples of what running a user flow with this type of profiling looks like, and what a single session looks like, that kind of are the grains that go into an aggregate analysis or to kind of guide your team. So this is an example of an app that's loading. So there's a purple bar at the top that's representing essentially what we consider to be the user experience of the page load. And then underneath the purple bar, there's a lot of other signals that are being correlated with that user experience issue that are around the root cause of different network behaviors. This is another example where the purple bar is a user experience issue of a page load. So it's taking about 15 seconds for this app to become fully consumable after the user taps the icon. Underneath, on the left, we have a bunch of root causes that we think are actually impacting, that aggregate user experience of the page load. Here's an example of just some straight up content issues. So sometimes, content's just not optimized for whatever the network condition is. So if your app is downloading content for 8 seconds before it has to load, that's a pretty clear issue, that can be addressed. On the left, there's some other examples like domain sharding, slow TLS, which is typically a server-side issue, and then as well as some insufficient caching. So we're seeing the same messages being sent multiple times to the client. So by having this high-fidelity PCAP data, you can actually start to really dig into what's happening, on this network at this time for this user flow. Here's a final example of a session where I thought this was kind of interesting because essentially there's almost a 2-second app load that's being caused by ultimately this app is too far away from its target region. So if you kind of look at the handshake times of the TCP connections from the client perspective, they're really long. This example of if this app is actually trying to support users in this region, they should really think about spinning up an edge closer to users over here to actually make this app load faster. So what we help teams do and how we apply our process is we spin up a bunch of devices as part of this global data center. We run these user tests, like we load apps over and over again 24/7, or we run critical user flows 24/7, measuring things like search, then checkout, or streaming a video, or whatever the top level metrics of a customer would be. We collect a bunch of these profiles, and then what we do is we put all this metadata about what was collected, as well as the real data in a kind of a separate area into a big schema, and the schema is sort of the beginning of creating these sort of large scale analyses of app behavior. So we've been collecting. For the past 3 years, we have a good number is we can run 5 tests per device per hour. And what that comes out to is you get over 40,000 high-fidelity sessions per device per year. So, as you're launching new versions, as you're measuring new user flows, a typical customer can see millions of these sessions in a year by deploying 40 to 50 devices. And what typically we look at after we deploy with a customer and create a bunch of sessions is we actually start looking at some of these key dimensions. They're really interesting to kind of start to break up your data by. So one is the actual devices that your users are using. So you have different devices in different regions. If you look at like the top 10 devices per region, there's some pretty high variation, in different regions. So if your app is, say, working on a Qualcomm processor in one region and a different processor in a different region, sometimes there can be variations between those, performance differences. So looking at sort of the breakdown of devices can be interesting. There's also carriers. So looking at how your app is performing on different carriers for different regions can be useful. Also locations themselves, so making sure that for each of your locations you're having sort of a uniform performance. So typically what you'll see is some locations are better than others, and that just means that whatever locations might not have been optimized. So maybe your edges are too far, maybe your CDNs are optimized, maybe you have some DNS issues for those locations, or maybe there are actually some location-specific issues, like there are a lot of app C issues, for example, in the Middle East, in Africa, because there are some unique challenges there. And as you're, scaling out, these are things to keep an eye on, right? What works well in one location might actually work well in another location, and this data through a process like this can help you understand from the user perspective what's working and what's not working. So we also look at network conditions. So there's sort of a natural curve for every location of the network between peak hours and off-peak. So it's actually really interesting to kind of start to look at peak behavior versus off-peak behavior, because even underneath your app, the network's changing throughout the day, and so are the services that your app relies on. So understanding, how things are scaling, as users scale up, but also the environment in which your app is running is changing, is really important. And having it from the user perspective, helps you prioritize how you're actually going to start to address these issues. A really useful thing to look across is versions, especially as developers go into continuous deployment or sort of continuous rollout of new versions. So making sure that you're accurately benchmarking new versions against old versions. Having the user experience data is a really useful way to do that from the user perspective, especially as you're rolling out new features. It's easy to see changes in those 6 user experience issues. So seeing more spinners, seeing longer loading times, or conversely, seeing things improve is always awesome. And also segments. This is a really interesting one, but essentially looking at other apps similar to yours, how they perform, what the baselines are, can sometimes be helpful, especially as, design is changing. The amount of data you're trying to show is changing. So it's becoming more and more common to have more autoplay videos, for example, in an app. Tracking, how is that actually performing? How is the state of design and the state of the app, changing in your segment, and how are you keeping up with that? Or it is really useful. And these are all things you can do, once you can collect the data, and actually run apps, as if you're running user studies. You can start to collect data, from different carriers, different apps, and understand how they work. So what we found is that through our study, most apps, the median user experience could be at least a second faster. So there's a lot of low-hanging fruit out there that can be optimized for most apps, most user flows. And having this type of data that helps your team, quantify, measure, and once you make a change, to measure the impact of that change, can speed up results and kind of cut down the noise. Make sure that you're focusing on the right problems, that you really do understand what every user sees in your app, and can actually save you a lot of stress if you have the right process from having to guess what to fix next. So so this process really starts from being able to automate a user flow. So to kind of get a sense of how things work, you can manually run user flows. You can hire people to run user flows, but to really get the scale and coverage to collect millions of data points, is you need to start with some automation. So luckily, there's some really awesome open source tools out there that everyone can start automating with. It's actually not that difficult to create automation and actually start automating apps to run through real user flows to see how they're working. So one project this is showing is called Appium. So this is sort of a UI front end to Appium. So Appium is great because it requires no SDKs. You can just load any app and run. So you can take your own apps, you can take third-party apps, you can take system apps. You can automate everything with Appium, and it's really nice that way. So if you go to the Appium website and download the Appium desktop tool, you'll see there's a tab in Appium desktop called Headspin. So that's our tab. So you can hook this tab up to our device cloud, our distributed device cloud, or some subset of that. and actually start running tests on these distributed devices. So what the recording process looks like for an Appium is this is part of the open source tool. Is essentially you see a screen of the device. You see sort of a breakdown of the components in the device, and all this is through the standard ecosystem provided by Android or iOS also. And you can actually start clicking around and clicking on elements, and it's actually writing Python code for you that you can then save into a script and then run anytime to rerun that user flow. So this is a very basic way to get going with automation, but it's actually fairly robust, and is a good way if you just want to plug in a couple devices to a computer and start creating user flows. This is a great way to start. There's a sort of a new direction happening right now, particularly around games and cross-platform testing and sort of more high-precision testing, which is image-based automation. So as of Appium 1.9, there's some new image capabilities in Appium itself, which is really exciting. So you're able to actually write tests using image matching. And then there's a really great project called AirTest that is all about image-based automation, and especially for gaming. It's very a little more sophisticated than Appium, but it's a great place to start. It's also open source. So these user flows aren't just apps with like hierarchies and stuff. You can use them on Unity apps. You can use them on games. Pretty much every app you can write an automation for, and it's not once you sort of learn these tools and maybe spend half an hour with these tools, you can actually start to see that creating automation and running automation is something that all developers can do. And then once you start hooking that up to more advanced data collection, the ROI on that automation just becomes more and more. So I'd like to reference a webinar that we gave earlier this year, because I think this is a really great introduction into writing reliable automation. So oftentimes what people will find is that you can get going with automation, but it's very brittle. It kind of breaks, or there's a lot of like timing issues and errors happening, and it's not really clear how to think about this stuff, right? Because typically when you're a developer, you think, you have to have 100% pass rate, otherwise it's it's broken. But actually, this idea of flakiness, this idea of dealing with unreliable systems, which actually real devices are very unreliable, is actually part of the testing ecosystem and part of thinking about testing. And if you think about it, you can actually deal with unreliable tests. You can deal with tests failing, every other run, and still get useful data. For example, so we put on a webinar earlier this year. It's on YouTube, and we actually did this with part of the someone who created Appium and maintains Appium, the lead architect Appium, and he actually went off and created a 9-part tutorial series about everything in this webinar. How to start really thinking about real world automation using real devices. How to get real data from automation, and you can find that on this Appium Pro link down there. That's the first of the 9 series. So, examples of what it means to manage flakiness is you can take the same test scripts and run them and get totally different results. So here I'm running tests on. This is like some notation that means 1 location, 1 device, 4 network conditions with 1 carrier. And I just ran this test 4 times, and the green means it passed. The gray means there was some kind of system failure, so like a test framework failure. And the red means the user flow just logically failed. So this is pretty typical. You can run this and you get all these noisy things. So what we found is useful is to really think about testing as more of a statistical process, not a purely deterministic process. So actually starting to define thresholds like the minimum number of passed tests, the maximum number of failed tests, the maximum number of system errors, and then working within those statistical thresholds until you meet some threshold, not so much trying to get absolute, 100% pass or whatnot. And when you start thinking about testing like that, you can actually start creating statistically useful and systems that will that you can maintain. So this example of basically taking an Appium script and running it on a Jenkins instance. So Jenkins is a continuous integration platform. It's open source as well. So all these tools are open source. And typically what happens is you take your Python that was produced by the tool, and you put it into a Jenkins workspace. And what happens is the script runs, it connects to a device that's connected to the integration server, and it runs the script. And then the script finishes, Jenkins saves some results. And typically here's where you would, for example, write into a database or sort of track the progress. So it's perfectly fine to get going with automation by just basically maintaining a Jenkins box and plugging some devices into it and writing scripts with Appium Desktop or AirTest. You can actually start getting some results this way. What we build Headspin to do is sort of take that and sort of make this process much easier. So not only provide the devices, provide the debug connection to the devices, but also have this 24/7 data collection on top of the devices and the tests that you just run a test, you get data. That's something also, if you get further into testing, you start actually seeing that how easily it is to automate these user flows. You can work with a partner to actually scale up your tests, get more data, get more coverage, and try to make this into a practice that your team can use to make better decisions. So that concludes my talk about continuous experience monitoring and the process we built at Headspin. And now, any questions? I'll pass the mic around. Thank you. Oh, okay. Yeah, great question. So the question is, in the presentation I mentioned being able to take your data and slice it up, compare other apps in your segment. And the question is, particularly around design, how you can quantify design and how design is changing for similar apps to yours. So one thing that is really interesting as you look globally is the design of apps, for example, in Asia is very different than the design of apps in North America. So in Asia, there's a lot of autoplay. There's a lot of content that's sort of automatically sort of streaming in. And a lot of sort of the state of the art of apps right now in North America, for example, let's just take like social apps is very intentional. Like you have to tap on something to view it. And you see some apps like Netflix, for example, starting to move more into like everything's auto-playing all the time. But obviously that requires more bandwidth, requires maybe a different backend design, right? Because now you have a lot of videos streaming in. So that's really kind of what I meant is, for example, if you're a travel app and you want to take the other top 5 or top 10 travel apps, how are they approaching user engagement? How is the user experience? And is your app achieving a similar result? That's what I meant. Okay. So yeah, this slide will be part of the standard deck, and thank you everyone for attending.